All right, so today we're going to talk about graphing polynomial equations using your calculator. So first, let's just take a look at this equation. So take out your calculator and take a minute, maybe put this video on pause, and go ahead and put this equation into your Y editor. So here I've done that. I put the equation into my Y editor. Now there's a couple of different ways that you can take a look at the graph. One way is to hit zoom 6. Now zoom 6 will give you a standard window from -10 to +10 on your X and -10 and +10 on your Y. But you see, when you use zoom 6 for this particular equation, you don't see anything. So this window is not big enough in order to see the whole function. Sometimes kids will use zoom either 9, or if you scroll down, there's another one, which is 0, which is zoom fit. So either zoom stat or zoom fit. Now, these sometimes I will use if I really am getting frustrated and I can't find a window at all. But usually they give you a window that's really not a good window. It almost just gives you a starting point. So for instance, if I hit 0 and then enter, you'll see I have an equation like that. I mean, a graph like this. So now you're going to have to ask yourself, is this window the correct window for my graph? So if you go back and take a look at what your graph was, you can see here that this was an odd function because of the 3 and a negative function. So you kind of know what your end behavior should look like. If it's that kind of a function, you know that it would sort of look like this here. Now, once again, we don't know what all of this stuff here does to my graph. It could have all sorts of maybe some other loop-de-loos in here that I don't know about. But all I'm really looking at here is my end behavior. I know that it should rise in the when I'm approaching negative infinity on my x's, and it should go down when I'm approaching positive infinity. So let's go back and take a look at our graph again. So here we have our graph. Well, I can see that it's rising up here, but I can see that it's probably going to tend to go back down if I add some x's. So let's go to our window and let's just add some positive x's. Let's go to 40. I'm just taking a guess here. So now you can see, I can see pretty much my whole graph. The only thing I don't like about this is this point right here, which we don't call a vertex anymore because I have more of them. So we call this a turning point. This turning point here is just a little too close, so I probably want to add some y's down there. So let's change our y minimum to, I don't remember what I said, 300 maybe. And now I can see that graph a little bit better, and I can see kind of all the twists and turns that it's going to be taking. So this would be a good graph, and I suppose if you wanted to get rid of some of these x's here to center your graph a little bit more, you could, but this would be a reasonable graph. So when you're drawing this onto your paper, you're going to draw a window about the size of the rectangle on your calculator. You're going to draw in your axes as you see them. You're going to make note of your min and your maxes, and you're going to draw what you see. Let's try another one. Come back to that one. All right, so go ahead and put this in your calculator. I'll do it while you do it. And if you want to go raise to the 6th power, this little caret here, you would hit that and then hit the number 6, and that would tell you raise to the 6th power. All right, so once again, let's hit zoom 6 and take a look what our graph looks like. All right, well, I can see a bunch of these squigglies all over here, but I have kind of a lot of white space, so I'm probably going to change some of my x values. And I kind of want to see the tops of those turning points, so I'll probably have to get some more y values as well. So let's see, I want to get rid of some of the x. So let's go like -3 to 6, clear up some of that white space on the x's. And for the y's, let's go -10, which it was, to, we need some more, I'll go 55. And now I can see all of the twists and turns on this graph. I can clearly see the turning points, so this looks like a good graph. So if I'm going back to my graph, right, you're going to draw your graph, you're going to put it here, and you're going to draw all the twists and turns that you see. Now let's go back to that graph for just a second, and let's just say, instead of doing zoom 6, let's just say you had set your window to -10, and let's say just you went up here to 2, and you graphed it. Now, if you take a look at this, this could follow your end behavior because you have an even and a positive function. So it looks like both ends are going up. But the other thing you need to think about is how many turns do you have? So if you take a look at kind of all of these different equations here, this here is a quadratic or a squared equation, and you can see this has 1 turn. This is a cubic equation, and you can see it has 1, 2 turns. Turns are where the graph changes direction. This is a 4th degree, and you can see I've got 1, 2, 3 turns. This is a 5th degree, and I have 1, 2, 3, 4 turns. So think about what generalization can you make about the number of terms and the degree on your polynomial. So the turning points is always going to be 1 less than the exponent, and that'll tell you how many turning points you have. Now that's just in general, because sometimes there are functions where you'd have to zoom in really, really close to see all of the turning points. So some of them are not quite as obvious as they are on this graph. For instance, whoops, that has to come in. But anyways, you'll see in a minute. For instance, if you put this into your calculator and graph it and find a nice window, you'll see that this is what the equation looks like. So it's, you can't clearly see 5 different turning points, but certainly this is still a good picture of the graph because we want kind of an overall picture. We don't necessarily want too much of a close-up because then we'll lose some of the other details. So if you have any questions on this, let me know.